Hi guys, Shouvik and welcome back to YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes, so today we have these problems. Maximum candies you can get from the boxes. Yeah, so this problem in overall this problem tagged as an hard, but like if you know certain graph traversal algorithms, then I don't think so. It's all together a hard difficulty problems. But yeah, like the variables that we have to like maintain to solve the problems to basically maintain the state of the like algorithms you are following, that is kind of complex. So for that we can consider it is an hard, but it is for sure an easy hard kind of problems, not like too much intuition, so you have to think of. Yeah, so in this problem statement, they have given you n boxes labeled from 0 to n minus 1, and you are given 4 arrays: status, candies, keys, and contained boxes, where status I is 1 if the ith box is open, or 0 if the ith box is closed. Very straightforward. Candies of I is the number of candies in the ith box. Very straightforward. Keys of I is the list of the labels of the boxes you can open after the ith box. You can open after opening the ith box. So keys of I basically, so every box should hold a list of keys. Every box should hold a list of keys. So that basically point that if you are able to open a box, then you will going to get K1, K2. Let's suppose if you are able to open box 1, then you are going to get K3, K4. So you are going to get the key of K3, K4 boxes. Now what you want? You need to find that boxes. If you are able to find the box 3 and box 4, then you already have it keys in your hand. So every box is a kind of treasure hunt. Every box is a kind of treasure hunt box. So inside that, the second parameters, if you are going through, so content box of I is the list of the boxes you found inside the ith box. So on high levels, if I can write the things to our OneNote quickly. So there are box for sure in these problems, and the box are numbered from. Please help me to draw a box. Please allow me. Not allowing. Now yes, allowed. So let's suppose that is a box. So like this way you have total of boxes from 0 to n minus 1. So that many boxes you have it. And every box should have three things. First things is candies. So this box should have some candies in it. Second thing, this box can hold some keys. And the last things is this box can hold another box or boxes. So inside that box there can be a list of keys and there can be a list of boxes. So inside that there can be child boxes, or there can be keys of some other boxes, right? So that is a treasure hunt altogether. And this box is altogether either locked, or this box is unlocked, So that is vended out by the variables of status. So status 1 means this box is open. 0 means this box is closed. Right? 0 means this box is closed. So these things, these informations they have tried to put on these lines of problem statement. Now if we can go further. So what else? Now they have given an integer array initial boxes. Now they have given another things of array of initial boxes that contains the label of the boxes you initially have it. So initially you don't have all the boxes from 0 to n minus 1. You only have this initial boxes. Now what you can do? You can take all the candies. In any open box. So on the initial boxes, the boxes they have given. So out of them, if the box is open, then you can take all the candies. Because that is an open box, you can take all the candies, and you can use the keys in it to open new box, and you can also use the boxes you find in it, because every box inside it can hold some keys and can hold some other boxes. So inside your boxes, if it is holding some keys, then using that keys you can open other boxes. So your gain is the candies that particular box is holding plus the keys that particular box is holding, and the third is the nested boxes it is holding. So these three your gain if the box is open in the initial boxes. Now we have to return the maximum number of candies you can get following the rules above. So I think the problem is not that much difficult in the very first go. So the variables, there are lots of variables that I am agreeing. There are lots of things, lots of informations they have put, but actually the problems is very childish. So if you can go through this problem statement, so there is like no dynamical way of to maximize your answer. That is very standard and static way. So you have to follow this state only. So you have to follow these orders. In orders, you are able to explore the candies. That orders or the state, like every explorables has a state. So that state you just hard-codedly maintain. You don't have any choices to do. We can either open this box or you can't. So we don't have any that thing. So on that perspective, I feel it's pretty straightforward, pretty easy problem solving. So if you can go through this problem statement. So this is the status, this is the candies, this is the keys to the array, this is the content boxes to the array, and this is the initial boxes. So you will be initially given box 0. So I know. So if there is a box is given to you, initially I will check if the box is open altogether or not. Yes, this box is open, this box is open, because at 0 we have 1, we have stored as 1. Okay, so this box is open. Okay, now then what? Then inside this box, we are going to get, inside that box, we are going to get some 3 out of 3 things. One is candies, second one is, tell me, keys, third one is nested boxes. So let's see what we are going to get. You will find 7 candies in it and boxes 1 and 2 and boxes 1 and 2. So these 7 candies you can take straight forward to your answer, and you are going to get 2 nested box 1 and 2. Yes. Do we have any keys? No man, we don't have any keys. So the keys till now we don't have any keys. So but we have 2 boxes 1 and 2. Okay. You have 2 boxes, no, 1 and 2. Now box 1 is closed because box 1 you can see it's 0, and you do not have a key for it. So you will open box 2. So you are not able to open that. But box 2, 0, 1, 2. So this box, you got 2 boxes, right? 1 and 2. But box 2, this box 2 is open. Oh, okay, my box 2 is open. Then what is the contributions to my answer for this box 2? Then I am going to get these 4 candies for sure shot. So my answer is 7 plus 4, 11 candies I have it. And am I going to get any new box? Okay. On 0, 1, 2. Oh, no. There is no nested box altogether inside this. But do we have any keys? 0, 1, 2. Yes, man. You have a key of box 1. So do we have box 1 in hand? Yes. We just explored box 1. Wait, it was a nested box inside the box 0. It was a nested box inside the box 0. So we have this box initially, but we are not able to open because we initially were not holding the keys. But after opening this box 2, we got the keys. We got the keys of whom? Box 1, and now we can open. Now in box 1 you will find 5 candies. So we opened it and we find 5 candies. So 7 plus 4 plus 5 is total 16 candies is currently in my hand. And box 3, 5 candies and box 3. But you will not find a key to box 3. So box 3 will remain closed. So now if you open this, did you find any key altogether new? No, this box, keys of 1 is holding 0, no keys. But we find a box, we find a new box. That is of box 3. But is it open or closed? Oh man, it's the box is 0, 1, 2, 3. This is closed. So you are not able to do so. You are not able to do anything. So the current state, what you are holding, it's lying as it is. So the total collections is 7 plus 4 plus 5. That is the maximum candies you can achieve. So now in this example test case, also you can do your iterations on your own, but I will do it on your behalf. So I guess you are able to explore all the boxes. You have initially box 0, opening it, you can find boxes 1, 2, 3, 4, 5. So initially you have given this box and this box is altogether open. And if you open it, then you got all the box and keys for all the box also. You got keys for all the box and all the box also. Now using the keys and all the box, you are able to open all the rest of the candies. So you will get all the candies, all the 6 candies. So the output is this. And here you can see like our constant is like in the range of our candies can as big as 1000, and our keys of I are all unique. So these are all together the constant. So your n can be as low as 1000 only. So I am pretty sure like if any kind of brute solution should be best fit. So there is nothing like we don't have any choice things. We don't have to take care of any extra case. We just blindly follow the rules. We can blindly follow the rules. So I am totally agreeing. The following the rules and maintaining the state for every jump or every levels is difficult. So that's the reason it's cracked as an art. But we don't have any dynamic kind of choices. We can blindly follow the steps altogether. So if we can go to our one node, so at very blank brain, if you are attending the contest in very blank brain, then what is coming to your brain initially? So okay. So we are bound to start with the initial box. bound to start with the initial box. So I am writing the intuitions or high levels, what actually way we have to think to basically maintain the state correctly, because state management is the problems for this particular problem. So the state we have to manage it very carefully. So at very initial state, we don't have any choices. We only will go through what is the initial box we have at. So let's suppose these are the initial box, and for initial boxes we have two choices. Either it is 0, so that means this box is open, or it is closed, right? So now let's follow the state management as it is. So for open boxes, so you are going to get, right? So we are initially at this state, then we will go to some this state, then maybe some state is coming to be this state, then maybe there can be some more states. So like this way we will be going to state wise. So if we are going to state by state, level by level, which algorithms coming to your brain? It's definitely level order traversal. Yes, agree guys, level order traversal or BFS. Yes, agree guys. We are doing level order traversal or BFS from last 2 to 3 videos. So you should be like very good hands-on on it. So what we need? We definitely need a queue to do the level order traversal. And we need few more things. Okay, what we need? So let's iterate the algo. We will find if we need any another extra value. So if this box is altogether open and it is in your initial box, then your answer should going to get the initial candies from here. So what is the state transitions? You can get the candies of this particular box which are open. Yes, I can get it. You can push this to your queue, because from there you can explore because that is an open box. So what is your explorations? If the box is open, then you can explore to get some keys or get some nested box, and the candies you are already getting. So you can do q.append of this particular box, because that is an open box, and mark this visited, because we will visit every box to be at max once, right? Agree guys? So we have just marked it to be visited of box. So now tell me what is the case if the box is closed? Then okay, now the box is closed, but that box, so we definitely need another variables, that is available box. So that means initially which boxes we already have at, but this box is not available, because which box? The box that we have already opened, that we have used, right? That we have already used. But this box it should be in the list of available boxes, because that box are available, but as they are closed, we are not able to open it. But that was in my hand. This box in my hand. Why I am not able to open it? Because I don't have keys and the box are open. So in that case, I will just put available box. Should be a set. I am taking it as a set. So you can push this box to be your available box, because I am not able to open it, but this is in my consideration. Now, what is the next step? So now we will run a simple BFS. Because that is the boxes that we have opened. That we have opened. So what we will do? We will do nn equals to len of q. That is of nn. Nn should be my len of q. So that is the levels of boxes we currently have at to my hand that we have just opened. Now what we can do? We can iterate a for loop in range. Tell me in nn. And what you can do? What we are generally doing? Very standard BFS we are doing. Here we are definitely running a while loop, while len of q. That you guys should be aware of, like, as we are solving that many problems daily. But yeah, I will do a code iterations also. But now on high levels, I am defining our algo. On high levels, I am defining our algo and building our intuitions. I am writing in kind of pseudocode only. So you will push this box got, that the box that you got on last go, I will push it q.popleft, because that is the very standard things. You have popped it to your queue, and now you are basically when you are pushing this to your queue, that means that box you have already explored. And on explorations, what you have explored? You have explored its candies. You have added to your answer to the candies only. But we have few more things. First one is keys. So I will write another for loop for key in where keys, they will give us a keys list of whom box got. So I will run a for loop of keys inside the keys of box got. So that many keys that particular box is holding. So I definitely need another variables. So I have already put a variables that is of available boxes. So I need another variables of available keys. So I will create another variables available keys. So that is basically holding which of the keys we currently have it, and I can make it as a default dict of int. I can make it as a default dict of int. So I will store what is the available boxes we have it and what is the available keys we have it. Now let's go forward. We are now in currently we are very good state to maintain our state management. We are doing it very correctly. So which of the keys we got, we will store it to our available keys of key. We will increase its count because we got a key for this box. Yes, very straightforward. Same things. Another things what we are going to get, box we are going to get, nested box we are going to get. In where? Tell me guys. In contain boxes, right? That is the nested box variables they have given. Contain boxes of box. Tell me. Contain boxes of box got. Yes. I got my box. Yes, I got my box. Now that is the box. That is the nested box. Now for nested box, tell me guys, when we have to think of that particular box altogether. If that particular box is not visited, then only we have to think. Otherwise we have considered. So this box should be visited of box should be equals to 0. So that means this box we have never explored. And if that box is never explored, then yes, I found one candidate. I found one nested box which can contribute to my answer. But there are choices, man. It's not able to contribute directly because initially also they have provided a initial boxes length, very high initial boxes, but we are not able to use them at all because some boxes are closed, because closed box are completely like not going to contribute to your answer, like completely like completely waste, right? The box which are closed are completely waste blocks until you have keys, right? The closed box is completely a waste box until you have keys. Agree guys? So now we have to check if the box is open. Oh, okay, your box is open. Yeah, your box is open. Oh, okay, your box is open. Then on that case you are very good state. Then you can mark your box, viz of box to be 1. It's very standard things. Candies of box of this, increase to answer plus equals to 1. Do it. Rest. Push it to your queue. Very straightforward things that we are doing initially. Q dot append of box, Q of append of box. Yes, we can do. If that is an open box, But if your box is closed. Oh, okay, my box is closed. Okay, fine. Then can we do anything? If my box is altogether closed, then also what we have to do, what we have to do. So initially think when we are doing here, right? When we are doing here, if on the initial boxes, if the box is open, then we have add to our answer. But if the box is closed, then what is the closed things? So that is the closed things. We have to do the same things here. Right? So if this is too slow, this one note. So if my box, so that is else block. Else block means if the box is closed. So here you can see if status of box is 1 and if status of box is closed. If that box is closed, okay. Then just push it available boxes. So that is an available boxes, but you can't use it, man, because I don't know if you have keys or not. So available box dot add this particular box. Now we can do the entire job. We can do our entire job for all the boxes of that particular level. We can do it for all the boxes of this particular level. And after this for loop is going to be over, right? Let me pull it when the for loops is going to be over. So here mostly your for loops is going to be over. That is, you have explored all the boxes. Of these particular levels. Then we have to check. In our available boxes for each in, or I can write it for box in available boxes. So that is the box we are getting. So if a box is in my available boxes and we have to check if available keys of that particular box is present. Oh, okay, man. So you have a available box. You have a available box for which you already have a keys also. Then on that case, what we have to do? Tell me. Q dot append this particular box. Answer plus equals to candies of this particular box. Then visited of this particular box is 1. And do we need this particular box to be stored in available boxes? Because we are going to run these for loops on every levels every levels expressions we will do to run a for loop for available boxes. So this box, can I consider this box has already processed this boxes? So available box should hold only that boxes which we have it in my hand and we have still not processed it due to two things. Either the box is closed, and if the box is closed, then on that case we don't have the key in hand. We don't have the key in hand to open it. So that's the reasons only. That's the reasons only. It is lying on my available box, but I am not able to use that. I am not able to taste the success, taste the candies inside the box. I am not able to add that candies to my answer because that is the reason. So if I am stating this box is already explored, I am done. I have used its contribution. So do we need any do we need unnecessary to lie this particular box to my available box? No, because that box has used. So I definitely need a variables here, box used. So I can initialize to be an empty list, and if we encounter that at any particular times this particular block is executed, then we can add it box used of append, but I can append it this particular box. And after that I want to remove that box. I want to remove this box from my available box for box in box in where box used, that is the box we have just used. And we can do what we can do, available boxes dot remove. I can remove this particular box. That's it, guys. That's it. Yes, we have to do only these things, and finally when my queue is going to be entirely my BFS has run, I can return my answer. These things you just have to follow in the order. See guys, like what the orders they have given, what's the way they have given to the problems. I have just followed that order and I am able to successfully maintain the state. Now quickly go to the code iterations once to understand in very depth in the line by line code iteration. So here you can see I have done exact same things that we have discussed. So n equals nq, that is of len of your status, and I have initialized my dq. I need a vis and I need an answer. I need two more things: current available keys, current available boxes. Current available keys are default dict of int. Current available boxes is a set. Yes. Now I can iterate what are the initial boxes they have given to us. For box in initial boxes, if status of box, if that box is open, then add it to your answer. Take the contribution, take the test of all the candies. By taking it to your answer, marked is visited, add it to your queue. All state are correctly maintained. See guys, like this way you have to write your code to your interview. So see guys, I named the variables in appropriate industry standard, appropriate production ready code I have written here, right? I named these variables only exactly the production ready way. So this nq, so that you can ask, Shouvik, you don't name them like in production ready. But yeah, like you can, that is like very straightforward. For n we are using for length. So that all we know, but you can name this like length, q, BFS q kind of things you can named it also. But yeah, like these variables is actually making more sense, right? Because that is this problem specific variables we are using. So for that reasons I have named it like very industry standard, very production ready. And if that particular box is closed, then okay, I am not able to open that box, but please put me to my basket as a available boxes. Put me to my current available basket of boxes basket. Yes, I have done. Now I am running while len of q, that is the very standard BFS that we are doing here. So these are the exact BFS things we have done. And finally, after the BFS has over, I have returned my answer. So now see what we have done. What cookies we have done inside our BFS. Now nn is len of q because we have to iterate to all entire labels we have to flush out, and new labels should we have to put. So this is the length of that particular labels of the nodes, and we are iterating to all the nodes. Right? Now we have couple of options. We have found our box got, that the box that we have found initially. So inside box candies we have already considered, but there are two more things. One is keys. I'm fetching the keys and I have increased the current available key. I'm storing that particular keys to my keys variables, current available keys, and I am now exploring the box. I am going to iterate for box in contain boxes, and if that box is altogether not visited, then only we have to do our job, right? If the box is visited altogether, then why you have to do your job? So if that box is not visited, then if that box is altogether open, then so that is the same case like on the initial boxes if the status is open. So in the nested boxes we have found one box that is already open, so take its advantage. Increase answer class equals to candies of box, mark visited of box to be 1, add q.append to the box, and if it is not, then we have two options. If this current available keys, if that box, so I am pretty sure that this box is closed. Oh, okay, this box is closed. No, okay, got it. So if that box is closed, then we have to check if that box keys is available. we have the keys of this box. Then to the case is same. Then to the case is same. Then if the keys is available, then I am doing answer plus equals to candies of box, visited of box to be 1, and Q on Q I am pushing the box. On Q I am pushing the box. Very straightforward. Else if the box is closed, if the box is closed, here this else stands for closed, and we don't have the keys altogether in hand. Then on that case, add to your available boxes. You are not able to use it. You are not allowed to use it because the box is closed and you don't have keys for it. No, you don't have keys for it. How you can use it? You are not able to do so. And now, after this entire labels we have flushed out, then we are running a for loop in our available box. So we will check what is the available box we have at, what is the available boxes we have at. So I will check if for any available box we have keys for same. So I'm iterating for box in current available boxes, and I'm checking if the keys of that particular box is present. Then same case. Increase your answer to be candies of that particular box. Mark is visited. Add it to your queue and consider that box. This box has already considered. This box is already considered because we have just pushed it to my queue. So I am adding it to my box considered list to append this particular box, because to flush our box current available box, because we need to flush to our current available. We can do a current available box dot remove of particular box, but we are not able to do so because when you have iterating to a particular variables on runtime, you can't change the size of a box. You can't change the size of the box. So that's the reasons we are not allowed to. When you are running a for loop inside for loops, you can't. If you are running a for loop inside a iterables, so this is a state, right? So which is a iterables. So you are not allowed to change its size when you are in runtime, when you are executing the for loop. So that's the reasons we need another variables that is a box considered, and we are storing this box we have just explored, and after that you can run another for loop to flush your available boxes, to flush this particular box you have just considered from your available boxes. So current available boxes dot remove, you are removing that particular box. Yes, the problem is as simple as that, but I am completely agreeing to you, all of you guys. The state management is the game. State management is for sure a game. If you are not able to like a very small to small minor things you have missed, no, on your available keys, available boxes, box considered in any part, if you miss the single line of it, then you are going to get a wrong answer. So that's the beauty. So that's the reason. Like you have to very too much careful to maintain every state transition. So when you are doing state transitions, you have to be a very be careful for this. So now we can quickly discuss the time complexity. So I think the time complexity is big of n only because what we are doing altogether, we are exploring every cells to be. We have reached the shit, yaar. I'm not seeing the time, but it is doing. So yeah, guys, like you can see, like my submissions is altogether 31% faster, and I'm pretty sure like when the more faster solutions is lying in the range of like this boundary only, that is of 13 milliseconds. So it is bound to be the most optimal solutions for sure. Now we can quickly discuss the time complexity that we are doing for every videos. So the time complexity, I am not going to iterate to every line's time complexity, but I am writing it kind of like high levels. So how many nodes we currently have at to my it. So that is of 1000 node we have it, and how many times we are visiting the nodes. We are visiting every node to be on single times only because we are maintaining visited. So there can be like, you can say that we are iterating to available boxes, so that is kind of takes some time, but on high levels, on big O terms, it is bound to be a big O of n only. But yeah, you can consider it is kind of a like big O, more than big O of n for sure. That I am also agreeing because your current available boxes can be as big O of n, and on that case you are for a single box you are going to iterate to the entire box for sure. But it is not going to happen in most of the cases because you can see, right, we are flushing out our current available boxes if we already considered it. But let's suppose on very worst case you are not able to consider it. So that's the reason I'm writing it kind of big O of n square, but it is not at all in big O of n square. But it is, you can mention it is a kind of amortized big O of n square for sure. And on space complexity, I think we are super good on this. So we are using only Q, this visited, this current available keys, current available boxes, which all can grow as big as how much big O of n? How much big O of n's? 1, 2, 3, 4. So 4n big O of 4n kind of complexity you can see. Yes, guys. So that is the most optimal time and space complexity for this particular problem that I am able to think of, and I'm pretty sure it is bound to be the most optimized time and space that is going to be set for this particular video. And I know this problem is kind of a tricky, but not as a hard time. It should be like medium hard for sure, because the state management is actually given. And if I have tried my best to best, I have tried my best to explain to you guys, like on every lines, every intuitions, that from intuitions building, from a box creations to intuitions building to every code iterations, why we are doing, in which points we are doing, and which state is going to be changed if we are not doing here this. So we have explained everything in details, and if you guys are able to understand till this point, so I will repeatedly requesting to you guys, please do subscribe to our channel, and please share the videos to your friends circle who are also preparing for top product based company, and please turn on the notifications so that when we are going to live to our next video, you will get the notification as soon as possible, guys. So that's it, guys. That's it for today. Let's meet tomorrow with another video question. Bye, guys. Bye.